So welcome back guys. In this video we will cover the remaining sums of the rotational dynamics chapter class 12 physics. So let's go to the remaining sums. A motorcyclist considered as a particle is undergoing vertical circles inside a sphere of death. The speed of the motorcycle varies between 6 meter per second and 10 meter per second. Calculate diameter of the sphere of death and how much minimum value are possible for these two speeds. So solution, we have been given a vertical circle and let's take this as the diameter of the circle. So the diameter will be twice the radius, so d will be 2 times r, and the range of speed for which the motorcyclist is traversing this circle is given between 6 meter and 10 meters. So we know that at top, that is Vh, will be 6 meter per second, and as it comes down the speed increases to Vl, which we can take as 10 meter per second, and again while rotating upwards its speed decreases to 6 meter per second, and comes while coming down it goes to 10 meter per second. So this is the height of the vertical circle. So here the h will be 0 and here the h will be twice the radius. Now in order to calculate the diameter we need to find out the radius. So by law of conservation of energy, we know that total energy at lower point will be equal to total energy at higher point. So by expanding the total energy in terms of kinetic energy and potential energy, we can say that half mv square L plus mgh, the height at lower point, it will be equal to half mv square h plus mgh, the height at higher point. So half mv square plus 0, because the height at lower point is 0, equal to half mv square h plus mg into 2r. The height at higher point is 2r. Taking half mv square h this side and taking 1 by 2m common, we can say that vl square minus vh square equal to 4gr. So taking this equation, we can write the radius, which will be equal to vl square minus vh square upon 4g. Now substitute the value. We know that vl is equal to 10 meter per second and vh is equal to 6 meter per second. So 10 square minus 6 square divided by 4. Let's take g as 10. So this will become 100 minus 36 divided by 40, which will be 64 by 40. So 4 tens are and 4 ones are 4, 4 6 are 64. So this will be 1.6 meter. So diameter will be twice of radius, that is twice of 1.6 meter, which will be 3.2 meters. So the diameter of this vertical circle is 3.2 meters. Now in the second part of the question, they have asked us how much minimum values are possible for these two speeds. Now we know that for an object performing vertical circular motion, the minimum velocity at top is given by root under rg, so which can be written as root under radius is 1.6 into taking g as 10, which will be root under 16. So the minimum velocity at top will be 4 meter per second. Similarly, the minimum velocity at bottom will be root under phi rg, which can be written as 5 into 1.6 into 10, which is nothing but 5 into 16. So taking 16 outside, 4 root 5. So the minimum velocity at bottom will be 4 root 5 meter per second. Let's look at the next sum. A metallic ring of mass 1 kg has moment of inertia 1 kg meter square when rotated about one of its diameters. It is molded and re-molded into a thin uniform disc of the same radius. How much will its moment of inertia be when rotated about its own axis? So initially there was a metallic ring which was rotated about one of its diameter, and then this ring was molded and remolded into a thin uniform disc of same radius. So the mass of ring was 1 kg. Now if this same ring is remolded into a thin uniform disc, so the mass of disc will also be 1 kg. Now the moment of inertia for the ring was given to us as 1 kg meter square, and we need to find out the moment of inertia of disc. Also one thing to note, that is the radius of the ring and the disc is same. So for this ring, moment of inertia of ring is given as half mr square. So 1 equal to half, mass is given as 1 kg into r square. So r square will be 2, which implies r is root 2 meter. Now this same radius is for the disc that the ring is been remolded into. So the moment of inertia of disc will be half mr square, which can be written as 1 by 2 into mass is similar to 1 kg, radius is also same, so root 2 square. So root 2 and square cancel, 2 cancel, we get 1 kg meter square. So when this metallic ring is molded into a uniform disc, the moment of inertia remains the same for the same radius. This was a pretty easy sum. Let's look at the next sum. A big dumbbell is prepared by using a uniform rod of mass 60 grams and length 20 centimeter. There is a dumbbell which is prepared by taking a rod of mass of rod is given to us as 60 grams and length of rod is given to us as 20 centimeter. So this distance is 20 centimeter. Two identical solid sphere of mass 50 grams and radius 10 centimeter each are at the two ends of the rod. So in order to create a dumbbell, they have attached two spheres. So the mass of sphere is 50 grams and radius of sphere is 10 centimeter. That is, this thing is 10 centimeter. We need to calculate the moment of inertia of dumbbell when rotated about an axis passing through its center and perpendicular to the length. So we need to calculate the moment of inertia when this dumbbell is rotated about this axis. So if this is at the center, this distance will be 10 centimeter and 10 centimeter from the center to the surface of the sphere. To find the moment of inertia of dumbbell, now we know that this dumbbell is made up of one rod and two spheres. So moment of inertia of the dumbbell can be written as moment of inertia of rod plus twice the moment of inertia of sphere, because this dumbbell is eventually the rod and two spheres. By calculating the individual moment of inertia of rod and the spheres, we can find the moment of inertia of the dumbbell. So first calculate the moment of inertia of rod. So moment of inertia of rod can be written as 1 by 12 into ml square, which is nothing but 1 by 12 into mass is given to us 60 grams. Let's keep all the units in CGS into L square, that is 20 centimeter square. So 20 into 20. So calculating this, 12 ones are 12 fives are, and 20 into 20 is 400. 400 fives is 2000 gram centimeter square. So moment of inertia of rod is 2000 gram centimeter square. So let's give this first equation and this as second equation. Now let's calculate the moment of inertia of sphere, but for this axis, not the axis which is at the center of mass of the sphere, but actually at the center of the dumbbell. To do so, we know that according to the theorem on parallel axis, I naught is equal to IC plus mh square, which implies that if this is the moment of inertia IC, okay, and we are rotating it from here, and this is the distance h, the moment of inertia will be IC plus mh square. So similarly, in our case, the dumbbell, the axis is here and the moment of inertia at center of mass for the sphere is given by 2 by 5 mr square, and this distance is 10 centimeter because the total length of rod is 20 centimeter. So this will be 10 centimeter, and this is the radius, which is 10 centimeter. So we can say that our h can be written as radius of sphere plus L by 2, which can be given as 10 centimeter plus 10 centimeter, which is 20 centimeter. So let's calculate the moment of inertia of sphere for the axis which is passing to the center and perpendicular to the length of the dumbbell, not from the center of mass of the sphere. So which can be given as 2 by 5 mr square plus mh square. Taking m outside, 2 by 5 r square plus h is 20 centimeters, so 20 square. Putting all the value, mass is given to us as 50 grams, so 50 into 2 by 5, radius is 10 centimeter, that is into 100 plus 20 square is 400, which gives us 5 ones are 5 20s are 2 into 20 is 40, and 40 plus 400 is 440. So 50 into 440 will be the moment of inertia of sphere. So this will be 22,000 centimeter gram centimeter square. Let's give this equation 3. Now putting equation 2 and equation 3 in equation 1. So we get moment of inertia of dumbbell equal to moment of inertia of rod, which was 2000 gram centimeter square plus twice the moment of inertia of sphere for the axis passing to the center and perpendicular to the length of dumbbell, which is twice into 22,000 gram centimeter square. So this comes out to be, this is 44,000 and this is 2,000, which is 46,000 gram centimeter square. I hope you got this sum. Let's look at the next sum. A flywheel used to prepare earthenware pots is set into rotation at 100 rpm. That is, N1 is given to us as initial frequency 100 rpm. This can be converted into revolution per second as 100 by 60, which is 5 by 3 rps. It is in the form of a disc of mass 10 kg. So the mass is given to us as 10 kg and radius 0.4 meters. A lump of clay which is to be taken equivalent to a particle of mass 1.6 kg falls on it and adheres it, which means that it sticks to it at a certain distance x from the center. Calculate x if the wheel now rotates at 80 rpm. So N2, that is the frequency when the lump of clay sticks to the flywheel, is 80 rpm, which can be converted into rps as 80 by 60, which comes out to be 4 by 3 rps. So this was our flywheel which was rotating, and a lump of clay sticks here at a distance x. The radius was 0.4 meter. So we need to calculate this x. So initially the moment of inertia for the disc, which is given as I1, will be half mr square, which will be 1 by 2, mass is 10 into r square 0.4 square, which will be 25, and 0.4 square 1.6, sorry 0.16, so 5 into 0.16, 0.8 kg meter square. Now the new moment of inertia when the clay is stuck on the flywheel is given by I2, which will be the initial moment of inertia plus the Ix, that is the moment of inertia of the clay, which is nothing but I1 plus mx square. Now for the given condition of the flywheel when the clay was stuck to it, and before that they haven't applied any torque So we can say that by the principle of conservation of momentum, L1 will be equal to L2. So we know that angular momentum is moment of inertia into omega, where omega is 2 pi and L1 will be I1 omega 1 and L2 will be I2 omega 2. So I1 into omega 1 is 2 pi n1 and I2 omega 2 is 2 pi n2. So 2 pi cancel, which implies that I2 will be I1 n1 upon n2. So we know what was I1, that is zero point 0.8 kg. So I1 is 0.8 into n1 was 5 by 3 and n2 was 4 by 3. So n1 will be 5 by 3 and n2 when it goes up will be 3 by 4. So 4, 3, 3 cancel and 4 ones are 4, 0.2s are and 0.2 into 5 will give you 1. So which implies that I2 is 1 kg meter square and the I2 is given as I1 plus mx square. So we can say I2 equal to I1 plus mx square, which implies that mx square will be I2 minus I1, which implies x square will be I2 minus I1 upon m. Now putting all the values, this m is for the mass of clay, so I2 was 1 and I1 was 0.8 and mass of the clay was 1.6 kg. So this will be 0.2 by 1.6. So x square comes out to be 0.125, which implies by taking square root on both the side, x will be root under 0.125, which is nothing but 0.35 meters. Now let's look at the last sum of this chapter. Starting from rest, an object rolls down along an incline that rises by 3 in every 5 along it. That is, we have been given a incline where the inclination increases by 3 units for every 5 units of the length of the slope. So this will obviously have an angle theta. Further, the object gains a speed of root 10 meter per second as it travels a distance of 5 by 3 meters along the incline. What can be the possible shapes of the object? So we have been given the velocity to be root 10 meter per second and the length the object rolls down is 5 by 3 meter. Now we know that rolling motion is usually performed by circular objects, that can be cylinder, sphere, wheel, etc. So in order to know what object specifically is performing the motion, we need to find the k square by r square ratio. That is, we need to find out k square by r square ratio in order to find out what shape of object was specifically rolling down the incline. So the velocity for rolling motion is given by v equal to root under 2 g L sin theta upon 1 plus k square by r square, which can be written as v square equal to 2 g L sin theta upon 1 plus k square by r square. Now separating k square by r square, the equation boils down to be k square by r square will be equal to 2g L sin theta upon v square minus 1. So putting all the values, 2 into, let's take g as 10 into L was 5 by 3 and sin theta. Now let's look at this incline. So this incline will obviously have an angle theta. Now applying sin theta, we get sin theta as opposite upon hypotenuse. So opposite is 3 units and hypotenuse is 5 units. So sin theta will be 3 by 5. So putting the value of sin theta here, 3 by 5 upon v square. So v is root 10. So v square will be 10 minus 1. So these things cancel, 10 10 cancels and this remains 2 and here 1, which will be k square by r square equal to 2 minus 1, which is 1. So the object corresponding to the k square by r square ratio equal to 1 is either a ring or a hollow cylinder. Hope you understood the sums that we have solved today, and if you have missed the previous part of this chapter's numerical solutions video, click on the I button, go and watch it. If you have any suggestion, you can write down below in the comments, and thank you for watching. Like, share and subscribe.